So here's the first example that we're going to look at as we actually start balancing some equations. So you should take a moment, maybe pause and write down that equation there. Those lines out in front that I put are where we're going to put our coefficients as we try to make sure everything balances. So what I'm going to do is I'm going to make that, as I mentioned before, that cute little table. And basically what I'm going to do, in this case, it's going to look like a tic-tac-toe table. Right down that middle column, I'm just going to list the different elements that are involved. So if I look at this equation, there's carbon, C, there's hydrogen, H, and there's O, that's oxygen. So I'm going to have those three down the middle, and on the left side, that left column, I'm going to count up how many are on the left side of the arrow, and on the right side, I'm going to count up how many are on the right side. So if I look here, I've got C, so there's just one carbon, H4, so there's 4 hydrogens, and then over here O2, so that's 2 oxygens. When I look at the right side of my arrow now, there's 1 carbon, there's 2 hydrogens, and then for oxygen I've got 2 over here plus another 1 over here for a total of 3. So now what I need to do is get everything to balance, to match. So right now the carbons, 1 and 1, those are all good. They're the same on both sides. But if I look at my hydrogens, I've got 4 on the left side and I've got 2 on the right side. So what I'm going to want to do is on the right side of my equation, hydrogens right here, I'm going to put in this blank here. If I want to get 4, I'm going to put a 2 on front there because that coefficient is going to be multiplying everything in this equation. So if I throw that 2 out there, that's going to change how many hydrogens I have down here. So I'll cross off on my table and replace it with 4. But it's also going to change how many oxygens I have because that's going to double these oxygens here. So I've got 2 oxygens right here and another 2 over here. So that's going to change that to be a 4 now, 2 plus 2. Now, if I look at the rest, okay, carbon's balancing, hydrogen's balancing. Now my oxygens aren't quite matching up. On the left side, I've only got 2. I want to get 4, so if I look on the left side of my equation, there's O2 there. If I put in this blank here, then a 2 times 2, that's going to give me 4 there. So that would balance everything on this one. Last little step would be just to fill in on each of these a 1 and a 1. And that would be our balanced chemical equation. They're not too bad. Let's take a look at another example. This one looks a little bit trickier here, so you should pause me, take a moment to write down that chemical equation, and then maybe to set up your table here. This table is going to have 5 rows because I have a few more elements involved. So hopefully you should pause me now. Hopefully you've paused and written some things down. I got a chemical equation. I'm going to write down my table, 5 rows here, and I'm going to put all the lead, chlorine, sodium, chromium, and oxygen down here. And you maybe should pause again to see, count up how many are on the left side and how many are on the right side. Make sure you're counting them accurately. If you don't know how to do that, the rest of the stuff doesn't work very well. Hopefully you've counted them up on your own now at this point. I've got 1 lead, 2 chlorines, 2 sodiums, 1 chromium, and 4 oxygens. Over on the right side, I got 1 lead, looks like 1 chlorine here, 1 sodium there, 1 chromium in our equation, and 4 oxygens. So if I start looking at the table, we'll notice, okay, leads are balanced. The chlorines aren't matching, but it looks like the sodiums aren't matching, chromiums do match, and oxygens do match. So if I just look at this chlorine here, chlorine on the right side is right there. And if I want to balance that, right now it's 1, I need 2. So in my blank out in front here, I throw a 2 there, and that's going to change the sodium and the chlorine, doubling both of those. So I cross them both off in my table, 2 and 2, and I'll notice now, oh, everything balances out. So even though this one might have looked a little bit more complicated than the previous one, it actually was quite a bit easier. That would be our balanced chemical equation. We throw the 1s into our other blanks, and we can put a box around that if we want, and that'll be our correct answer there. Okay, so I'm going to end this short video here, and there'll be one more. We'll do a third and final example that you'll need to check before you go on to your assignment. So